Okay, well, it stopped in the computer stopped in the middle of my thing, so this is going to be part 2 of beginning factoring. Algebra 1 course, here's part 2, and when the computer freaked out on me, I was at this problem. So let's finish this problem. First off, we're noticing what these two have in common. They have in common n minus 3, so we'll take that out on its own. N minus 3. We look at what remains, the factors that remain. Here, after we take n minus 3 out of the first portion, the remaining factor is n. When we take it out of the second, there's nothing remaining. And in multiplication, when you need something, 1 doesn't change it. 1 times n minus 3 is the same as n minus 3. So what remains here after it's taken out is the factor 1. And it's plus. So that can be written like this. Okay. This is factored. They are both factored. This is a factor. And this is a factor. And this is a factor in the other one, and this is a factor in the other one. They are all factors. Okay. Why are they factors? Because they're something that's multiplied. It's a group, but who cares? It's in parentheses. We don't care if it's got a plus or a minus in it. It's a group, and the group is used as a factor. It is multiplied. Okay, next thing up. We're going to practice. So practice these. Pause your computer and I'll get the answers. Okay. Here are the answers. Notice that number 9 and number 10 can be a little bit problematic. Go ahead and check out the answers. Number 9, the two terms in parentheses had the same value, but they were not exactly the same orientation. 13 plus x and x plus 13, same difference. Addition is commutative, which means you can write it in either order and it'll be the same thing. So just choose one of them. I happen to have chosen 13 plus x, but x plus 13 is just fine. They are the same. It's a little more problematic in number 10. In number 10, you notice they look very similar. In the parentheses, the groups in the parentheses, there's a y, there's a 4, and there's a minus, but they're in a different order. And since subtraction is not commutative, it changes the value of it. So what we do is down here, we'll start with just the second term, the second portion, and I'm going to change that parentheses to look like this one. You can do it either way. You can make this one look like that one, but they need to look the same. They need to be just exactly the same or you can't factor it. So what we'll have here then is, you know, if you just take a number, you take 12, multiply it by negative 1, you get negative 12. Multiply that by negative 1, you get 12. Anytime you take something, multiply it by negative 1, and then do it again, multiply by negative 1, you come back to the same thing. Multiplying by negative 1 twice has no effect on the value, and we're doing it here for convenience because we want these two to look the same. So I'll multiply a portion of it by negative 1, a portion of it by negative 1, which is the same thing. Do it twice. 5 times negative 1 is negative 5. 4 minus y times negative 1. When I distribute the negative 1 and rearrange it in descending order, I see that it's y minus 4, which is exactly what I want it to be. So now I have rewritten problem 10 like this. And the portion in parentheses to be the factor that's removed is y minus 4. And it works just the same as the others that you've done. Okay. Next up, We've got 4 terms here to be, and we're going to factor these equations, these expressions. Arrange them in descending order. Some of these do not necessarily have to be in descending order, but it's a lot easier if you do it in descending order sometimes. Anyway, it looks proper to do it in descending order, so we'll just go ahead and do that first. Let's look at the first ones. The first problem here. It's already in descending order. We're going to take it 2 at a time. I'm going to do these first 2, and I'm just going to ignore the last 2. Okay. What do both of these have in common? What factors? Well, that's a cubed. The 1 is the coefficient. 5, that's nothing in common. A cubed is 3a's. A times A times A. A squared is 2a's. A times A. Oh, wait, they have A times A in common. I can factor out A squared. After I take A squared out, when A cubed divided by A squared will be A. Let's see, let's check it. A squared times A is A cubed. Yep, I did it right. Okay. When I factor out or take out the factor A squared, what's left here? Well, 5. Did I do it right? A squared times 5 is 5a squared. Yeah, I did it right. Okay, let's do the other portion. On the other portion, what do they both have? Well, it looks to me like there's a plus and that they both have a 3. 3 has a factor of 3, and 15 has a factor of 3. So I'll remove that factor by dividing it out. After I take it out, there's an A left. Does that work? Yes. 3 times A is 3A. Okay. And 15 divided by 3 is 5. Does it work? Yes. 3 times A is 3A. 3 times 5 is 15. That worked. Now we're going to do it one more time. Just like we were just doing. We now have a common factor. Our common factor is A plus 5. We'll write it to the side after having been factored out, and then check what's left over. What's left over from the first grouping is A squared. From the second grouping is 3, and it's plus. So that is our factored form. We'll do the same thing again for our other problem for a little more practice. Again, it's already written in descending order. Doesn't always have to be, but it is usually convenient and it does look right. So let's start with the first one. What do they have in common? They have 3c squared. Then the leftovers here would be c and minus 1. Does that work? 3c squared times c. Yep, that's 3c, 6c. Ooh, I did it wrong. 2c, sorry. 3c squared times 2c is 6c cubed. 3c squared times a negative 1 is negative 3c squared. Okay, let's go to the next one. Okay, the next one is going to be plus, and it looks to me like they just have in common 4. This will be 2c minus 1. Oh, look, it worked again. If you don't get exactly the same thing in the group in the parentheses, then you can't do this. Now, sometimes you might be able to change it a little bit, like we did on the last one with multiplying by negative 1 twice, which doesn't change the value, but makes it convenient for our purposes. If they're not the same, you're done. There's nothing else you can do. Okay, these are the same, so we can take out the common factor, 2c minus 1. See what's left after we remove that factor, 3c squared and plus 4, just as we were doing before. Okay, so now this is factored. Let's do a little bit of practice. Here we'll practice. Okay. Pause the computer, practice these. I'll put the answers up. Here's the answers. Make sure you're working them right so that you can get them done. And here endeth the lesson.